Alright, this is the intro to Decimology. This is the first video I've made on the topic. Let me go ahead and start off by giving you my name. I am Albert Renshaw. A lot of people call me Albert Einstein. My middle name is in fact Einstein. I'm Albert Einstein Renshaw. And decimology, it's basically, well, first off, it's a field of mathematics that I invented. It has to do with patterns, and I've been working on it for probably about a year right now. The current date is June 27th, 2011, but I've been working on this way back into the start of 2010. And let me give a generic definition. It basically has to deal with the patterns found in math that can't be described through algebra, but they are there, and hopefully they'll help us understand numbers, and I don't know, computing sequences can get faster, maybe figure out the pattern, the primes. Hopefully this will open up a whole field of cool stuff. Alright, so there's a lot of notation I've invented, so I'm gonna have to make some notation videos before I can really get into some of the more recent patterns I've discovered. But let me start off with just an example, and the example I'm going to be using is the first pattern I figured out, the one that really started it all. So with this pattern you can solve any problem that's an integer. So let me see, an integer. Well, it doesn't really have to be an integer, I guess. I guess it could be any number divided by 9 equals x. And I'll show you how to solve x using this pattern. And with this pattern, you can solve any number divided by 9. It doesn't have to be an integer. I should have drawn the all complex numbers symbol. Divided by 9, you can solve for x without a calculator using this pattern. So it's non-algebraic, so let me start off with an example and I'll show you how it works. So we'll say 137 divided by 9. Actually, I'll come back to this one. First off, let me just give you an easy one. 123. You'll have to forgive my handwriting. It's a little bit hard to draw on the computer. I'm using my laptop mouse right now, or my laptop built-in mouse. So there's no stylus, but equals. Alright, here's how the pattern works. Basically, when you're dividing by 9, the answer is going to be just the number and then plus all the previous numbers. So 123, I mean, writing any number, let's say 13 is the same as 0, 0, 0, 0, 0, 0, 13.0, 0, 0. So there's zeros going forever in both directions, and then you just have this one number here in the middle. So 123 is actually 0, 0, 0, 0, and then there's a 0.000 on this side. So you have to keep that in mind kind of when I'm adding all the previous digits. It's like 1 plus 0 plus 0 plus 0, so that'd be the first one. Then 2 plus 1 plus 0. Alright, so let me go ahead and, without further ado, the pattern here would be for the first digit in the answer, which I'll just notate that for the first digit. It'll be just this number. Technically, the first digit is going to be a bunch of zeros because we're taking the first number plus all the previous. So 0 plus 0 plus 0, we have a bunch of zeros, and then we get this number. It's our first number that isn't 0, so that's where we write it. You know, you don't write out 0, 0, 0, 13, you just write 13. So 1 plus 0 plus 0 plus 0 is, in fact, 1. And the second digit, 2 plus 1 plus 0 plus 0, that will be 3, because 2 plus 1 plus 0. All right, and then the third digit, 3 plus 2 plus 1 plus 0 plus 0 plus 0 plus 0 is 5 plus 1, which is 6. All right, so 6. And then the fourth digit is, and remember 123 is the same as 123.0 barred, so we'll take the first 0. So it's 0 plus 3 plus 2 plus 1 plus 0 plus 0. So it's another 6. And the next one, since it's only zeros after that, it'll just keep being 6s after this, so 6 barred. And this is the answer without the decimal point. The way you get the decimal point, typically it's just one less than the number of digits. Like if our decimal point is after 3 digits. So we have up to 100's place, and then we put a decimal point, then it'll be 10 here. So if there's 4 digits, like we had 1,234 point blah 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 divided by 9, then the answer is just going to be 3 digits point. So since we have 3 digits here, we're going to go 2 digits, 1, 2, and then we're going to put our decimal point. So 13.6 barred. 123 divided by 9 equals 13.6 barred. Let's test it out. 123 divided by 9, 13.6 barred. Let me go back to our original example that I was planning on doing. Let's see. How can I erase? I'm still learning this software. You'll have to forgive me. I believe if I fill these in. Yeah. Alright, that's cool. It's working. Alright, so our original example, we had 137 divided by 9. And there's just one basic thing I'm going to have to teach you about decimology, and that is notation for having a number greater than 9 in a digits place. Right now if we want to write 37, right, we can write 38, we can write 39, but then it becomes 40. You can't write 3010 because that would look like 310. So the way you notate this, if you wanted to write a 10 and then a 3 in the next highest digit place, would be 310. You notate it by putting these little sideways brackets around it. And basically, if you want to convert this into standard numeric form, you just take the 10, you'd carry it over till you get to the next, you'd carry you can only have one digit in this place, so you're carrying all the higher digits, the digits that make it greater than 9 over. So if we take 1 out of here, then we have a 9, so we can carry, I'm sorry, we take the 1 out of here, then we have 0, 0, so the 1 would get carried over into this one, so that becomes 3 plus 1, which is 4, 4, 0, 0, and 0, 0 is the same as just 0. There's 0, 0, 0 is 0. Just having 2 zeros is still the same as 1 0, so 40. So if we had in the same digits place, 117, 6. This is a 3-digit number, right? There's only 3 digits. We just have a 17 instead of a 7 or whatever here. We have to carry it over so that we only get to 1 digit to convert it to standard numeric form. So we're going to carry the 1 over, and that cancels that, right? So 1 plus 1, we're carrying it over to this one. That becomes 2, 7, 6. So 117, 6 is the same as 276. And that's just standard addition. That's carrying over. We're just notating it differently. So without further ado, I can start working on our original example now. That notation needed to be learned in order for this part to make sense. So let's do our pattern. We're going to have a 1, right? And that'll be our first digit. And then a 3 plus a 1 plus a 0 plus a 0. So our second digit is 4. Alright, then a 7 plus a 3 plus a 1 gives us 11. And that's 1 digit, keep in mind. It's not 1, 4, 1, 1, it's 1, 4, 11. And then the next one, we're going to have a 0.0, so 0 plus 7 plus 3 plus 1 is still 11. And then we have infinite 11s after that, so we'll bar it. Now we have to convert this to standard numeric form. So we're going to carry the 1s over, starting from right to left. So this 1 gets carried over, so now we have a 12 here and a 1 here, right? Alright, but now this, we can't have a 12 here, so we got to carry the 1 over. So this 1 gets carried over to this 11. So now we have a 12 here, and this just becomes a 2, right? And then we carry this 1 over to the 4 here, okay? So this just becomes a 2, and the 1 carried over is 1 plus 4. So we get 5, and then there's nothing to carry over, so this is still 1. And if we add another 11 here, which we do since it's barred, if we add that 11 here, we would have carried it over, and this would have been a 2, and then the next 11 would have made this a 2. So it's actually 2, 2, 2, 2. It's actually 2 barred. So now we have 1, 5, 2, 2, 2, 2, 2, 2, 2. And this is 3 digits, right? So we're going to go 1 less than that. We're doing 2 digits till we get our decimal point. So 15.2 barred. And let's check that. 137 divided by 9. 15.2 barred should be the answer. 15.2 barred. So the pattern does work, and it's non-algebraic. And that's one example. There's many patterns I've discovered. I'm going to be making more videos soon. If you're watching this after the month of June in 2011, there's probably already some videos up there. I might even make some more tonight, but I'm definitely going to have to add a notation section to the website so I can describe all the notation I have. I have tons of symbols, and a lot of the videos, a lot of the patterns aren't going to make sense unless you understand the notation. But this is just one example so you can see how a pattern and division by 9 works, and how you can, I don't know, impress your friends dividing by 9 in your head really easily. Or if you're using a computer, you're building a program, you can maybe create division by 9 simply and make the program run faster. You know, especially when you get into decimals, you can do stuff. This pattern works for any number, not just integers. So like 137.69231, something like that, you'd still be able to solve it. And that's pretty much it for now. Be sure to check back, and let me put my email in this video. I don't like to put emails in the actual website themselves because lots of programs pick that up, and they always seem to send me spam. And before I started putting my email on the internet, I never got spam, so there are robots out there getting that, programs. So let me just put my email down here for y'all, and you can feel free to email me if you have any patterns or questions. All my methods, everything I talk about, you know, feel free to publish stuff like that, but please, please, please contact me first. I'd love to have credit given where credit is due, you know, and it's weird nowadays if you're researching something like I am, creating this new field. If I'm putting it all online, you know, it's great for me because I get to document it, and I get to spread the word, and everyone learns about it. But at the same time, it's very easy for someone else to pick it up and then publish it in a higher, with more connections, you know, in a higher field, and be given credit. So if you do want to use my findings, please contact me first and make sure that, you know, I'm okay with it, and I'll be given credit. That's always a good thing for me. So thank you for watching this. I hope you are intrigued as I am. And again, this is a Decimology.com video. Here's my email address if you want to email me. I'll go ahead and put my, you know, I hope that none of you are putting this this video on other websites without my permission. But if you are watching this on another website, here's the Decimology.com. This is my website. This is where I upload the main videos, and I hope you'll go here. It really supports me seeing a bunch of views on this site. So that's the site if you want to go to it. I hope you will, and I'll see you later. Thanks for watching.